Now we'll look at equipment setup, which is a continuation of what we were talking about earlier on our last video. Setup is very, very important because if you make any mistake, you are going to suffer in quote. There have been a case of personnel turning on something like suppression to 30%, or some people not even changing something as simple as velocity, and their values became problematic. So before we go into this, my long list for 0-degree equipment setup, I just want to put this point out, which is very, very important. UT equipment are different manufacturer, different architecture, different setup. It is very, very important that before you try setting up a UT equipment, especially if it's the one you are just using for the first time, read the manual. I will not stop emphasizing this. Read the manual. Even the best, even the experts, even level 3s, when they get new equipment, they take their time to study the manual so that it becomes easy. A lot of the information that you will need to set up and eventually calibrate your equipment very well, you will find them in the manual. And there are some very, very hidden things that if you don't read the manual, you are not going to find out. We will see some of them as we proceed. So this is a very long list. It may not be exhaustive and it may not suffice for all UT equipment, but this generally should give an idea of what you are going to find in most UT machines. So the first thing you are going to do if you are setting up equipment is universal for all the equipment. You are supposed to set the velocity. That is the first thing you do. So there is a reason why I wrote set or select velocity. Some machine that you are going to see will give you the option of a drop down. So for example, if you look at the Sonates series, when you go to velocity, there will be a drop down where you see steel. Say steel, stainless steel, aluminum, and so on with the required velocity. When you are using such units, what you just need to do is to go down the drop-down menu and select the one you are actually testing for the material. You also need to be very careful for steel, for example, if you are using shear wave or if you are using a longitudinal wave. For 0-degree, you are definitely going to be selecting longitudinal. So in that case, you are selecting. There are other units, for example, the Olympus series. It does not give you this drop-down menu. Rather, it will give you a space where you either increase or reduce the value until you get to the right velocity that you want. So those are the options that are available. The same thing applies to range. In some units, it will give you a drop down with the possible range. A very popular machine with this for range is your Sonates D50. You are forced to select. Even the earlier versions of the D series, they give you options of the range that you can take. So you just select. In some other units, you are supposed to set. Then this is very important before you proceed, because it might eventually affect some of the values you are going to get. So just go around the unit. Some machines have delays. Some have delays only. Some have zeros only. Some have zeros and delay. You need to set whatever value you are seeing in the delay, set it to 0. Whatever value you are seeing at the 0, set it to 0. Some units have what we call suppression. Suppression and reject are actually the same thing. So it all depends on the nomenclature that the machine is using. So normally it will be in percentage. So please send this to 0. Especially for this suppression and reject, most of the jobs you are going to do at your basic level and majority of the UT job, you don't need it. So stay away from suppression and reject. because this definitely will affect whatever you are getting in your A scan for whatever value you're seeing it to. Do not go there if you don't need it. So you set all this to 0. Then the next thing you need to look at is to set the probe velocity. There are some UT units that have broadband frequency. In that case, you don't have to set frequency. Immediately you connect your probe, the machine will just work based on the available frequency in the unit. So there is no limitation to that for those that use broadband. Example is your Sonatex D50. It has a broadband frequency, so you won't see any button that will require you to select or to set frequency. But in other cases, you need to select the frequency of your probe. One might ask, if I have a 2.25 megahertz probe and I decide to set 4 megahertz, is there any effect? Physically, looking at the machine, you may not see that effect. So the thinner the material, the more the frequency that it can produce. So if I have a very thick material or a very thin material and I introduce the wrong frequency, it definitely might affect this. And in some cases, you can even have probe physically breaking because of a vibration. So it's very, very important for you to put the right frequency and ensure that the frequency that you are using matches with the probe. Irrespective of the probe you see, for all the probes that you are going to be using, you always see the frequency written in the body. Like if you look at this case now, you see that the frequency is 4 megahertz. So you are supposed to always use the right frequency. Then the next thing you set is your PROF, your pulse repetition frequency. For your normal flaw detector, for your conventional UT, you may not physically see the effect as you will see in the case of PAUT, where the result of your PRF directly affects the volume of the data that you are acquiring and also the display that you are getting on your, say, your B scan or your C scan. So in this case, you remember in the concept of PROF is this. So let's say we have a probe, a 0-degree probe, and we have a material. Say this is the material. How it works is it's sensing this ultrasound signal, it hits the back wall and comes back. Now, the UT signal is not a continuous signal. That means it does not move continuously. Rather, it pauses. So it sends them in form of pulse. So you have this, just an illustration that way. So the idea is if you send in a UT signal, it goes in and comes back with the reflected echo. The next one goes. The time interval between this, let's say I send 3 pulses, the time interval between each of these pulses that you are sending will be determined by your PROF. So which means if you have a very short PROF, it means as you are sending one, the next one follows immediately. The next one follows immediately. If you have a longer PRF, it means when you send in one pulse, you wait a little time, you send in another pulse. If you have very, very high PRF, it's going to cause what we call crosstalk, or rather not crosstalk now, noise. It will cause noise because the returning echo will start interfering with the echo the returning echo will start interfering with the ultrasound that you are sending in, the one that they are transmitting. So if you have too high a PRF, the incident signal will not be interacting with the reflected signal, thereby leading to a form of noise in your unit. It may not be something that will be obvious to some people, but if it gets very high, it will cause some distortion in your signal and even affect your results. Now, rule of thumb, when you have a setup you want to do in UT or any NDT equipment for that matter, and you are not sure of the right value to pick, my advice generally is pick a middle value. So let's say if we have the lowest PROF to be say 40, and you have the highest to be say 15. If you are not sure of what to do, just pick the middle value. That way it won't be so low or so high. So this is very important. After setting PRF, the next thing you want to set is voltage. Some unit will call it voltage, while some other unit will call it energy. The unit is usually in volts. It is the same concept with frequency. The higher the voltage, the more the vibration, the more the energy that is being used. And you want to keep the voltage low, because if the voltage is also very high, if I have a very thin crystal that is consuming so much voltage, it can also lead to breakage of the unit and can also generate noise too. So you want to keep the energy. If you are not sure, keep it in the middle. In some units, they will give you the option to automatically set it or manually do it. When you see auto, even both for PRF, when you see auto and manual, the general rule of thumb is use auto, because the machine will take the optimum PRF and the optimum voltage for you, so you don't have to go through the hassles of trying to adjust or determining which value gives you the right result. The next thing is damping. Of course, we know that if you allow a UT signal to continuously, if you have a pulse, it produces what we call ringing. And if you want to reduce the ring time, you do what we call damping. And we know the whole concept of damping will affect your resolution. We know that highly damped UT pulses will produce very short pulse width and give better sensitivity. But you don't want, because you don't want to damp so much that it starts affecting the results you are going to get. So if there is automatic setting, stick with the automatic. If there is a range of value, if you are not sure, pick the middle value. But if you want specific result and you know what you are doing, then set the right damping value. The next thing you want to set is the UT test method. In some units, they will tell you UT mode or UT technique type. Depending on the nomenclature that is used, they are all asking you to either select either your pulse echo or your DOA or your true transmission. In some units, they will not give you this. The general assumption is that when you see 0 degree, it's going to be pulse echo. Not really. But in some cases, will not give you this option. They will give you an opportunity. Instead of picking this, they will give you either single element or dual element, not the angle. If you don't see something like this, you will see single element or dual element. Now, your single element is pulse echo. Your dual element can either be pulse echo or dual, or pulse echo or true. In some units, this dual you see can do pulse echo or true or the normal dual. Now, just to give a little background on it, just a little explanation on the technique. The whole concept of the pulse echo means a probe, either with one crystal or a probe with two crystals. In the case of one crystal, one is transmitting and the same one is also receiving. In the case of dual crystal, one is transmitting and the second one is receiving. This is pulse echo. Pulse echo is one probe, which is the key word. One probe. So the one probe could do pulse echo, it could also do dual in some units. The dual in this case could mean one probe, but with two elements. In another case, you have this dual, but not one probe. In that case, it becomes two probes. And in that case, you are not doing it as pulse echo. Immediately you start bringing two probes. You are either doing true transmission or you are doing pitch and catch. Always have this at the back of your mind. Immediately the probe changes from one, it is no longer pulse echo. So because if you are doing true transmission, for example, it means that if this is the material, one probe will be on top and the other probe will be at the bottom, and you are going to be moving them. Immediately you shift them out of alignment, it's no longer going to give you any reading or echo or whatever, because you have missed it. So for true transmission, you are going to jig this together and you begin to move them around. So that is a separate topic for another day. So you need to understand the whole concept of the technique you are dealing with. Some units will give you this option, some units will give you this. Know what you are doing and understand concept. In some other cases, some will give you 0 or they will give you angle probe. But know what you are doing. The next thing is to set your pulsar. Normally, we are talking about whether it is spike, whether it is tone burst, and the rest. If you can help it, don't bother going this way. Do not set it. It's not necessary for you. The machine will determine it. In some cases, like the case of a Nortex 650, is already set on spike. So just leave it like that. Do not play with that. Now, from number 4 to number 9, they usually fall under what we call the pulsar. If you get a UT unit, in principle, you have what we call the pulsar setup. You have what we call the receiver setup. So in your pulsar setup, you have your pulse generator, your synchronizer or your timer, and the rest. And they all work with this information. So this falls under your pulsar. Some machine will put it under your pulsar, or in some other cases, they will scatter it all over the buttons of the unit. But just know that whatever thing you are doing here, you are affecting the pulsar. What do we mean by the pulsar? Whatever is being generated by the probe to the material. Then number 10 and 11 has to do with the receiver, which is your output signal that is coming from your UT machine. So the options that are available, you can set your filter and you can set your rectification. Your filter, as I will always also advise, leave filter alone if you don't understand what filter does. Don't go and start setting your band passes, your high pass, and your low pass. You'll get yourself into trouble. So just leave it alone if you don't know what to do. Rectification, most of the work we do for our conventional UT, we'll be using our full wave rectification. So forget about half wave, because if you are doing half wave, it means you are cutting off one part of your signal, and that can lead to some. Because if I have a wave that is like this and I'm doing half wave, I could either be doing half wave positive or negative. We are going to have this gap here, which we don't need. So even though in your UT machine, you are seeing, because somebody has asked that our echo is coming like this. Why is it coming like this? Even though we select full wave. So that is a different conversation, but just choose full wave for what you do. Your radio frequency, normally you use that in your TOFD and some other units. For example, your 38 and 39 DL thickness gauge, they normally give you their results in ROF. ROF is the signal that will come like this. Just like that. So that's your ROF signal, radio frequency. So then the last thing you are going to set, which is very, very, very vital, is to set your trig. Some unit will put it under the menu they call trig. Some others will scatter it all over your machine. In your trig, because this is ultimately what is going to affect your result at the end of the day. Your probe angle, your material thickness, your S value, or some machines will call it index points. Your probe angle, because you are doing 0 degree, is always going to be 0. Your material thickness, it may not really be consequential when you are doing your 0 degree setup and calibration. But in shear wave, when you start doing weld inspection, you are going to impute the right material thickness. Hence, if you don't do that, you are going to be having um, wrong thickness reading or depth reading when you see indication. For your 0 degree setup, your S value will be 0. That is your index point. So the index point does not really apply when you do your 0 degree setup. So just set it as 0. Then the last thing you are going to do is to set your test type. This is very important, especially when you are using units like Sonatest. Monitor is just giving you are just using the UT, your probe to just search the surface to see variations and see how the echo comes out. You may not get any reading. But if you are going to be doing thickness measurement, please choose thickness measurement. There are other options in the case of Sonatest. You can choose edge to edge, gate to gate, flank to flank, echo to echo. So it all depends on what you are doing. So you need to set it. It's very important for units like Sonatest. If you don't set it, it's going to affect the kind of results that are coming out from whatever test you are doing. So basically, this is just a rundown of setup. Like I said earlier on, this is not calibration. This is all just you setting up your equipment to get it ready for the actual calibration. It is when you have done this for your 0 degree that you now perform the actual calibration. So let's move on from this.
So when you look at the angle probe setup, it's basically the same thing with your 0 degree. But take note, for angle probe, you are trying to do your word scan or what we call your shear wave. So the very critical factor in this is your technique. But basically, you are doing the same thing for your 0 degree. You are doing your range, your frequency. You are setting all this like you will set in your 0 degree. The major thing you need to consider, you can see I said it there, is the technique. When you are talking about technique, the technique is very vital. You remember we talked about our pulse echo, and we talked about our dual, and we talked about our true transmission. For your angle probe, the true transmission may not apply. In your pulse echo, it could be one element or two elements. That's two crystal or one crystal. So in that case, you can pick your pulse echo. When you talk about dual in your angle probe, you are looking at a possibility of two options where you are doing your pitch and catch. So for pitch and catch, for example, you can do, let's say I have one probe here and I have another probe here. They are facing each other. So one transmits and one receives. You can have another version where you are doing pitch and catch. You have the probe facing, instead of facing each other, they are facing the same direction. This is basically used when you are testing for very thick material. So you probably have an indication that comes this way, hits at this point, and goes up. So this is another version of pitch and catch. But in this case, the probes are jigged together. So this distance is usually constant. Unlike this, where you keep one probe permanent and you are adjusting the second probe to see where the backward echo is going to come out. We normally use this when you are doing transfer correction. We'll talk about that in some other videos later. So when you are doing transfer correction, you use this kind of pitch and catch. But in that case, you can still do your dual, depending on the unit you are using. Some units will allow you to even do your pulse echo. But where you now have the difference, if you are looking at this kind of units now, if you are using two probes, one goes to the transmit receive and one goes to your normal receive. So you are using two probes, but you can decide to select your pulse echo or you select your dual. It all depends on the unit you are using and the setup. So technique is very, very, very important. Another thing you are going to look at when you are talking about your angle probe is your velocity. The velocity for shear wave or your what we call your what's it called now? Your transverse wave is quite different from your 0 degree, which is your longitudinal wave or your compressional wave. So you need to select the right velocity. We've had cases where personnel go for job and they make mistake of still leaving the longitudinal velocity. There is no way you are going to calibrate it. You adjust your zeros and you will not get the right calibration. So you need to be very sure that you have put in the right velocity for shear wave, which is your transverse wave. Now, when you come to your trig, this is very, very, very critical. Because when you are doing your shear wave, you have a possibility of angles. Instead of your normal 0 degree that is just one angle, you have your 45 degree, you have your 60 degree, and you have your 70 degree. You have some other newer units that give you the option of 35 degree, like your Sonates D50 gives you this option for 35 degree. But your commonly available probes are 45, 60, and 70 degree. You need to choose the right angle, because if you don't choose the right angle, you are going to be getting wrong results. Because basically, if let's say this is a material we are trying to test, and you probably have your angle probe, if it comes like this, it's going to provide you with 3 readings. So you have your surface distance, or what we call our skip distance, we have our depth, and we have the beam path. All these are all dependent on the probe angle, which is this. So if you choose the wrong angle when you are setting up, the values you are going to be getting for these 3 parameters will be wrong. Even when you do your indexing and all that, still, as long as your angle is wrong, you are going to be getting wrong value. So you need to select the correct angle. The next important thing you need to set, which is very, very key for your angle probe, is your material thickness. And if you look at your units, the same idea. So I have a material, let's say this is a weld. Let's say this is a weld. If I put my probe, we are going to be getting reading in what we call our skip distances. If you don't put the right thickness, when it gets to this point, this is normally will be the thickness. When it goes to the next skip, it's going to consider this distance as increasing. So if say here is 20, by the time it hits this place and keeps going, it will see this next skip as another 20. So if I'm getting the distance around this area, I'm going to be getting the distance, let's say 35 mm as my depth, which eventually will give you a wrong reading. So it is very, very key when you are doing angle probe to impute the material thickness. Very, very important. Even if you are using a different calibration, maybe a calibration that you have saved, by the time you get to the feed and you get the right material thickness, impute the material thickness before you start scanning. Yes, you make mistakes. The next thing that is also very important for angle probe is your index point. The index point is actually the exact point from your probe. So if I have a probe, let's say I have a probe. Let me draw a bigger. This is a probe. You have your probe crystal, which usually is not on this face of the probe. So the UT signal comes in and breaks the surface of the probe and enters the material at a particular point. This distance from the face of the probe to this point where the UT signal is coming out is what we call the index point. In some probe design, you will see a big marking here, but you want to be sure whether the index point is actually coming out at that point. If it is not, especially for old probe, it is your duty to determine the index point. That will be discussed in a separate video, how to determine the index point. But when you get the index point, you need to impute it into your UT machine. If you don't do that, it might give you wrong readings for the surface distance. Also, by the time you impute your index point, it eventually will affect the values that will be coming out when you start taking your index point. One of the advantages you get for imputing your index point, when you are taking measurement, you can take measurement from the face of the probe. So when you are checking if you are getting the right defect, you take your measurement from the surface instead of coming to the inside. This points to measure because the unit automatically does the calculation and does the subtraction for you. So more details of this will be talked about when we look at index point as a separate topic, how to impute it, how to get it imputed into your machine, and how it affects your final reading. But you must impute the index point when you are doing your equipment setup. Somebody might ask, if I don't do my index point, if I don't impute my index point, will it affect my calibration? The answer is no. So you can take your time, do your setup, do your calibration, then come back later and impute the right index point. You will still get your results. So basically, this is what you do when you are calibrating for, when you are setting up, for your angle probe for wet scan and shear wave inspection. And that was wrap up the setup for angle probe. And next we will talk about the calibration.